Good evening there, Winterweb. Today we're going to write rational expressions in lowest terms. Wouldn't you love to get your hands around the throat of the people that come up with this stuff? Goodness gracious. First of all, if we have any number, and we typically write any number as x, but it doesn't really make any x, divided by x, any number divided by itself is 1, right? 15 billion divided by 15 billion is 1. Now, if we have AB divided by BC, okay, again, any number divided by itself is 1, so we end up with A over C, right? Right. Now, if we have, for instance, if we have 30 divided by 72. Now, we can factor 30 into 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. And then 72 we can factor as 2 times 2 times 2 times 3 times 3. Right? I think so. The 2 divided by 2 is 1. And 3 divided by 3 is 1. So what are we left with? 5 in the numerator, and 2 times 2 times 3 is 5 over 4, and what was that, 12? All right. Now, all this kind of gets back to, or kind of morphs into 14, let's say, k squared divided by 2k to the third. Now, what are the factors of 14? First of all, is 2 times 7, and k squared is k times k. And 2 is a prime number. 2 times, now k cubed is k times k times k. Base number times itself 3 times. 2 divided by 2 is 1. K divided by k is 1. So we end up with 7k. Oops, sorry. There's another k there. So we have 7, not k, over k. Okay. Now we can get this into, you're gonna see more and more of these if you have 2y squared minus 8 divided by 2y plus 4. 2y plus 4. Now what can we factor out of the numerator? We can factor a 2 times y squared minus 4. Okay? Now y squared minus 4 is what? It's a conjugate, right? Always look for these because it's going to help you out. Now again, what can we factor out of this? We can factor a 2, y plus 2. Now that's not a conjugate, obviously. And so now let's factor the conjugate. That's 2 open y plus 2, y minus 2 closed over 2 times y plus 2. The 2's cancel, and the y plus 2's cancel. And we're left with y minus 2. Okay, be sure and look for the conjugates. They're going to make your job easier. And let's do another one that's kind of like that one. 3x minus 12 divided by 5x minus 20. Now what can we factor out of the numerator? 3. x minus 4 over, is that right? I think so. And what can we factor out of the denominator? 5 open x minus 4. X minus 4 is cancel, right? Any number divided by itself. Remember, the parentheses makes that one number. So we have, we're left with 3 over 5, right? And what if we have this? M squared plus 2m minus 8 over 2m squared minus m minus 6. Now we need to factor the numerator, and when we factor this, we're going to get, what are the factors of negative 8 that are going to add up to this? It's going to be 4 and 2. M plus 4, m minus 2 over, now we want, excuse me, take 2 times negative 6 is negative 12. And what are the factors of negative 12? Well, you can factor that one on your own. I'll tell you, it's going to come out to 2m plus 3. And m minus 2. The m minus 2's cancel. And we're left with, can we do anything with the m plus 4 and the 2m plus 3? No. We end up with m plus 4 to m plus 3. Right? Right. Wasn't that fun? Okay. Those problems, they really don't get any much more difficult. They just get longer. Just like we've been saying all semester long. Okay. Now we're going to solve OLVE. Linear, L-I-N-E-A-R. Linear just means makes a line, a straight line. Linear inequalities, I-N-E-Q-U-A-L-I-T. Linear inequalities. Inequality just means less than, greater than, less than, equal to, greater than, or equal to. And we're going to solve them with graphing, the graph, and interval notation, I-N-T-E-R-V-A, interval, T-A-T-I-O-N, interval notation. Sounds tough, doesn't it? Well, it's not. It sounds tough. So first of all, let's take something easy. So if we have x is greater than negative 3, now if we were to graph that, 1, 2, 3, 4, 5, 1, 2, 3, 4, negative 5. Now negative 3 is 1, 2, 3 here. And before I go too far, if we have greater than or less than, you use parentheses to show. So on this particular one, we're greater than negative 3. So greater than are all these numbers out here. Greater than, we would use parentheses, because when we're saying greater than negative 3, it means all of the numbers up to negative 3, but not including negative 3. It doesn't include negative 3. So it's all of these numbers. And the easiest thing to do is take one of these numbers, like 5. Is 5 greater than negative 3? Yes. So we went the right way. Okay. And take this one step further. Greater than or equal to, less than or equal to, we use brackets. Right? Right. Because the brackets show that it includes the number. Okay, so what if we have this? If we say that A is less than or equal to 2. We haven't done the interval notation here. We'll do that in a minute. Okay, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, -5. Less than or equal to 2. 2 is right here. Which way is less than? Less than is that way. Greater than is that way. Now, we're less than or equal to. So less than or equal to, we use brackets. And that way. Is 0 less than 2? Yes, so we went the right way. Okay, now interval notation just mimics, kind of looks like the same as the graph. What's on the low side? What's the least this number could be? Goes all the way forever, so that's negative infinity. Now, negative infinity does not end, so we use a parenthesis because it doesn't include any number there. And what's on the high side, what's the most this could be, is 2. And 2, we use a bracket because it includes the number 2. Right? Right. Okay. Now, when you solve inequalities, A-L-I-T-I-E-S, is the same as equations, except, seems like there's always an exception, doesn't it? Except if you multiply or divide by a negative number, G-A-T-I-V, a negative number, the sign flips. The inequality sign changes. Okay. Solve inequalities exactly like you do equations, except if you multiply or divide by a negative number, the sign flips. So if we have this, if we have 3a plus 2 is less than 17. Okay, the first thing we're going to get rid of is addition and subtraction. So we subtract 2 from each side, and we get 3a is less than 15. Now we're going to divide by 3. Now we're not dividing by a negative number, so our sign is, is not going to flip. So a is less than 15 divided by 3 is 5. And how would we graph that? 1, 2, 3, 4, 5. Okay, less than 5. Now remember, less than is this way, greater than is this way. And it's less than, so we're going to use a, where are we? Less than or greater than, we use parentheses. Okay, so we're going to use a less than, a is less than 5, so we're going to use a parenthesis opening this way, goes forever. Now the interval notation, what's the least this number can be? What's the least a can be? Negative infinity with a parenthesis. And what's the high side? What's the most this number can be? 5. And it's less than, so we use a parenthesis there also. Okay. Okay. And what if we have this? Negative 2b. See, now we're going to end up, we're going to have to divide by a negative number, so we know our sign's going to flip. Plus 3 greater than or equal to negative 9. Okay? Now, again, we're going to solve this just like an equation. So we're going to get rid of addition subtraction first. So subtract 3 from each side. Negative 2b greater than or equal to, what is it, negative 12? I do that. Now we divide by negative 2. When you divide or multiply by a negative number, the sign flips. So think of, we're dividing by a negative number, so equally, whatever that means. Okay, so now B, instead of greater than or equal to, is going to be less than or equal to, because we divided by a negative number. And a negative divided by a negative is a positive 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now here's our, it's less than or equal to 6. That means it includes the number 6. So we're going to use a bracket opening this way because it's less than. And if you're not sure which way to go, just take a number, any number. Take zeros always seems to be the easiest. Is 0 less than or equal to 6? Yes, so we went the right way. Okay, again, what's on the low side? What's the least number that B can be? Again, negative infinity. What's the most it can be? 6. Now it includes the number 6 because it's less than or equal to, so we use a bracket. Okay? Those are really pretty simple. They get a little bit longer, but they really don't get any more complicated. This is when you stop and take a drink of your Diet Coke. Set operations. If we have that, let's say that A equals the set of numbers 1, 2, 3, and B, the set of numbers that are B are 2, 3, and 4. That was stupid. Okay, if we say this, A with a little horseshoe looking thing, that means A union B. Okay? It means that the set of all numbers M, actually it's elements. These are called elements in here. The set of all elements that belong to sets A or B. Okay? So in other words, it's all of the numbers that are in here. So A union B are going to be, okay, 1, 2 is in both of them, 3 is in both of them, and 4 is in one of them. So it's all of the numbers. And if you were to put this in a circle graph, or a, what do you call those things? Okay? It's all of the numbers. Now, if we have A intersect B, Just think of the road out. Oops, sorry. Just think of the road outside when you're at an intersection of the road and there are cars all in the road. It doesn't include the cars that are on the road. It's just the ones that are in the intersection. Okay, so if we have, so in other words, what we're saying is the set of all numbers that are in A and B. So which numbers are in A and B? So our A intersect B, B are which numbers are in both of these? Is 1 in both of them? No. Is 2 in both of them? Yes. Is 3 in both of them? Yes. Is 4 in both of them? No. Okay? Okay. Get this if you're so smart. Let's see. Where is all my paper? Here we go. You're going to see probably just one of these on the final exam. Okay, so if you're given this, given that A equals the set of all numbers, or the set of the elements, 1, 2, 3, and B is 4, 5, 6. Mm-hmm. Okay, so A union B, remember, means what numbers are in A or B. Remember, this means 4. So it's all of them. 1, 2, 3, 4, 5, 6. Okay? Now, A intersect B. Is 1 in both sets? No. Is 2? No. Is 3? No. 4, 5, or 6? No. So we don't have any in there. This is why I don't want y'all to draw a line through the 0, because this means something. This means the null, N-U-L-L, the null set. In other words, there are no elements in both. Okay? Wasn't that fun? Mm-hmm. Now, compound inequalities, C-O-M-P-O-L-I-T-I-E-S. Okay. So if we have this, if we have x plus 3 less than or equal to 8 and x minus 2 is greater than or equal to 0. First of all, we're going to solve these. I know this looks like a bunch of misery here, but it's really very simple. It's what numbers are in all of this. So we're going to subtract 3 from each side. So x is less than or equal to 5. Now we didn't multiply or divide by a negative number here, so our sign does not flip. Add 2 to each side on this one, and we get x is greater than, stupid boy, greater than or, be a moron, x is greater than or equal to 2. Okay? Now, let's graph these. 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, -5. Okay, x is less than or equal to 5. Here's 5. Less than or equal to is going to be a bracket because it's less than or equal to, which means it includes the number 5. And x is greater than or equal to 2. Greater than is this way. So it's only these numbers in here. If you're not sure, take a number like 0. 0 is outside. Is 0 less than or equal to 5? Yes. But remember, it has to work for both of these things. Is 0 less than or equal to 5? Yes. Is 0 greater than 2? No. So this is not in our area. Only that one. Now, if we were to do interval notation, on the low side, it's going to be 2 with a bracket because it includes the 2. And on the high side, the most this number can be is 5, again with a bracket. Right? Right. Okay. Now what if we have this? First, take a drink of your Diet Coke. Mm-hmm. Negative 2x plus 4 less than ultra. And x minus 3 is greater than 2. First of all, let's solve these. I'm going to subtract 4 from each side. Negative 2x is less than 8 minus 4 is that 4? Now we're going to divide by negative 2. You go, híjole. So our sign is going to flip. So now x is going to be greater than negative 2. Now this one, we're going to add 3, add 3. So x is going to be greater than 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. So x is greater than negative 2. Negative 2 is here. Greater than, we use a parenthesis. And here, x is greater than 5. Okay? So remember, what numbers are in both of these? Only this. This is the only thing that goes in both. Right? Right. Okay, I'm really out of time here. Well, maybe not. 30 minutes. I think we're okay. Let me do one more of these that's, no, that's okay. We'll do that one in class. All right, y'all take care. Bye-bye. Bye, Bonds.